Let's set up stateless auto configuration on a router. Now, why might we want to do that? Well, we might have a router that doesn't need its IPv6 address statically configured. And we don't want it to obtain its IP address via a DHCP server either. So instead, we can tell that router, get your IP address via auto configuration. So what that means is that there must be some other router attached to that router's interface. It could be on a local area network with more devices, or it could be point-to-point between two devices. Regardless of how it is, that router simply needs to receive a router advertisement message from another router. However, in order to enable this process on our router, we have to go to the router interface, as we can see here, and type in IPv6 address autoconfig. By doing so, stateless address autoconfiguration is going to be used on that router interface. So when the router advertisement is sent by this router, and it arrives at this router here, since it's set up with IPv6 address autoconfig, it's going to take that /64 prefix that's advertised by that default gateway. It's then going to use EUI64 to generate the latter 64 bits of its IPv6 address. Now, what about the client here? Well, the client is also going to receive that router advertisement message. However, since this is a Windows PC, depending on the version of Windows or the service pack that has been upgraded on that PC, it could either use EUI64 or it can randomly generate some random 64 bits that it's going to use for its interface portion. But the important thing to realize here is that on our routers, by default, they're not going to auto-configure their addresses. We have to turn it on with the IPv6 address autoconfig command. But on a what? On a what? A PC. Oh, that's done by default. We don't have to do anything at all. They're just going to automatically configure their IPv6 addresses, and they're up and running. Plug and play. And always remember that when you're doing stateless auto configuration, IPv6 unicast routing must be enabled on the router that is sending the router advertisements. The interface you want to send router advertisements out of has to be enabled for IPv6. So it either has to have the IPv6 enabled command on it, but more importantly, it needs an address. It needs a global IPv6 address that it can advertise to those devices at that particular interface. So it has to be more than enabled. You need that IPv6 address, and it has to be a /64 prefixes. If it's anything else, the process won't work. The clients will ignore that. So for example, if they get a /63 as the prefix, they're going to look at that and go, nope, can't do it. Can't do it. Why? Because they're missing one bit that needs to be there to generate their address, and they can't do it.